Hello, welcome back to another episode of 0 to 60. It's hot today, even though it's storming. Maybe the weather knows that we are doing the fuel system, and it's going to be a hot fuel system. Hopefully it doesn't catch on fire. God, I should make those jokes. Right, guys, today we're doing the fuel system, or at least starting the fuel system on the Flomax turbo car. Now, the whole point of this car is to go faster than my 17T car. I want to see this, if we can, roll 700 wheel horsepower on the dyno that my car rolled 625. That means we're going to be pushing around 800 horsepower at the crank. To make 800 horsepower at the crank, you need a lot of fuel. Now, I don't really want to get into a debate about direct injection or over-driven direct injection versus port injection. There seems to be a pretty clear divide in the M54 tuner community between DI only and port injection. I do think DI only is fine for low power cars, like your 500 crank. Seems to work pretty good for that. Even, you still really need an overdrive. I don't like the overdrives, but all the powerful cars are on port injection, not just on this platform. If you have an unlimited budget and you're trying to make your Lamborghini Huracan go as fast as you can, you use port injection. And on a per cylinder basis, they're not miles away from what we're doing with the M54 world at this point in time. I think port injection is better than direct injection. And until people start showing me draggy slips that say otherwise, I'm going to stay that way. So we have a port injection based system right here. It's all laid out on the bench. This is well and truly tested because it's from our single turbo car, O'Reilly. Now, I hope Dan from Simply Tuning doesn't mind me sharing his brilliance from 5.5 years ago when he built this fuel system. Sorry if you do, Dan. But man, I know you're doing much cooler, much smarter things now. This was put together in 2016 when Dan built O'Reilly and did its first 9-second pass, and it works. I've seen the logs when this thing's running. I've seen the logs of this thing on the dyno. This fuel system will make the best part of 1,000 horsepower at the crank. O'Reilly was around that 900 horsepower when we had it on the dyno, and the fuel system was doing absolutely fine. So let's just talk through the components that if you're going to replicate this, you're going to need to buy. You should buy a port injection manifold. These things are relatively cheap for what they are. It allows you to build your port injection into the manifold itself. The design of the manifold is supposed to increase flow for the high power applications versus stock plastic one. It also won't pop when you're running that 30 PSI like the plastic ones do. Lots of different places to get them. They're all made in China. They're all the same, to be honest, and there's no one's better than the other. We have 1,000cc fuel injectors. Now, to be honest, we could probably hit our power goals with 700cc injectors, maybe even a little bit smaller, especially the way that we're going to have the fuel pressure at the port injectors. But these come out of O'Reilly. We're going to need bigger ones when O'Reilly comes back together, so it made sense to just reuse them for this. I know a lot of guys run 1,000cc injectors in N54s. It's going to be fine. Just here we have our flex sensor. This is a genuine General Motors flex sensor. I've got the fuel lines, the two AN adapters that we're going to use to tier into one of these fuel lines. We've got the Motiv Flex Fuel Flex Analyzer. Yeah, that's a mouthful, but that's there. That's obviously going to give a signal to MHD or the stock DME and tell us what ethanol content we've got in the tank, and it will also help us scale the port injection for the different ethanol blends, because you need more fuel when you've got a higher ethanol blend. I have a used split-second AIC controller. I would like to be running a reflex, I'm not going to lie. I like the extra features of the reflex, especially being able to add additional sensors. The reflex still isn't CAN bus integrated on an N54. That's probably going to be when I actually take my money out or beg, borrow, and steal to get one. For now, the AIC is going to do the job. Yes, it's batch fire. Can someone show me that batch fire is worse? Because a lot of people can't tell the difference, especially when you drive them, and especially on a dyno. But I know sequential is better, but this will do for now. The difference is not that big. Here we have a bucket, which is a factory bucket that's had its bottom taken out. In there are two Walbro fuel pumps. One's a 460, one's a 525. I don't know why there's 525 in there. Don't know if we need it. It's something that a lot of people get confused with. I know you can buy off-the-shelf N54 fuel systems that have 3 Walbro 460s. Like, on a port-injected Falcon, one Walbro 460 will make like 600 wheel horsepower. Why are people putting 3 of them in an N54 that makes 700 wheel horsepower? It's a bit weird. I feel like there's a lot of places that just sell products to sell products, not necessarily because they actually make your car work better. Anyway, we got two Walbros in the bucket It is a bucket list system, but you may notice there's no special brackets in there. The pumps are just loose. This was built 5 years ago, and it's fine. Don't overthink your low-pressure fuel pumps in the bucket. Everyone seems to. Just here we have another little another little fuel line, which actually links the fuel that comes from the back of the car up to the factory fuel rail. And then we have a boost reference fuel reg. The O'Reilly was done pretty damn well. Obviously, it was quite a good, well-built car until we blow it up. Dan actually used a braided vacuum line on everything. So that is actually just vacuum line. It's not fuel line. That is a fuel line there on the regulator. Now, the way that that works, it will increase the fuel flow to the rail based on boost. And the idea of that is that as we have 30 PSI in the intake manifold, we can increase the fuel pressure by 30 PSI. I've just realized why he used a 525 fuel pump. Anyway, don't worry. You guys probably worked that out before I did. That way that basically the fuel pressure in the rail might be 90 PSI. Fighting against the 30 PSI on the engine will equal 60 PSI at the injectors, which is where my car currently struggles. So my car, I don't run an external fuel reg. I'm just running off the factory fuel reg. So if I'm only getting 65 PSI on my log, the fuel pressure at the injectors is actually only 40 PSI, 35, 40 PSI. So my injectors won't be flowing as much as if they were getting 60 or 70 PSI. That's where this makes it brilliant, and that's what makes the port injection flow a lot more fuel, more power. Now, to help a few of you guys, in case you're watching this as a guide, I suppose, to build a fuel system, you need to understand how the stock unmodified fuel system on an M54 works. You have one of these buckets that isn't cut up and it has a single fuel pump in there. That fuel pump is controlled by the fuel pump controller, or the EKMP or PM, and that sends a PWM signal to the factory fuel pump based on the fueling needs of the engine. So at wide open throttle, high RPM, high load, it can basically wind the fuel pump up and get more pressure to the front of the car, or more fuel to the front of the car. Remember, the stock system is not a return system. It does have a fuel pressure regulator in the fuel tank. This side has the fuel pump assembly, that side has the fuel filter and fuel pressure regulator. The factory fuel pressure regulator, I don't know if anyone's actually checked pressures, but from what I can understand, it basically bleeds off around 75 PSI. Correct me if I'm wrong. But yeah, it looks like you'll make whatever PSI on this side of the tank, it'll go over to there, and when it goes over 75 PSI, the fuel bleeds back over to this side and actually refills the bucket. Now, a lot of guys, actually this car is one itself, we have a Walbro 460 in the standard location running off the standard PWM signal. So this car would actually be flowing a lot more fuel than the standard small little fuel pump at the same amount of volts or PWM. And even though it's making a lot more fuel pressure, that extra fuel pressure never exceeds that 75 PSI that gets sent up to the front of the car. This car logs okay on MHD. It doesn't really make any boost, so it's not really straining the fuel system at all. It's definitely not straining that 460. But because of the way the factory fuel pressure regulator works, you never actually get that much fuel going up to the front, because anything over 75, it just bleeds back to the bucket. Now, the stock fuel system goes from the fuel pressure filter regulator assembly up to the front of the car and straight into the high pressure fuel pump. The system was never designed for port injection, so it goes straight. That actually flexible hose there is coming out, well, it joins down to the factory regulator, and then it goes into the high pressure fuel pump. That turns the 60 to 70 PSI into a few thousand and goes up into the direct injectors. Now, we are adding port injection. Port injection simply just flows a hell of a lot more fuel, and that's how we make power. Don't forget, like a really fast car, like a drag car, they don't even use electronic injectors. They just pump the fuel through jets, essentially. When you're making power, you don't need the finite control that direct injection has. It's great for efficiency, not needed for power. So what we're going to do with this system is add another Walbro. So it's already got one in there. We're going to add another Walbro, and that Walbro is going to be connected up to the front of the car directly. So it's not going to go through the factory fuel reg. So it's not going to have that 75 PSI limit that's currently there on that side of the car. And that's, I think I mentioned it before, but that's what my car has. It doesn't matter. I could put 20 Walbro 460s in the boot, goes over 75 PSI, the fuel stays in the fuel tank. It never makes it to the front of the car. And it's going through quite a small fuel line as well. So keep that in mind. What we're going to do is bypass the fuel pressure regulator with the secondary pump. Now, the secondary pump is activated on this car through this little hob switch here. So it won't actually turn the secondary pump on until we're making more than 14 psi in the intake manifold. As soon as we go over that 14 psi, the secondary pump turns on. You may notice the hob switch is in the intake manifold. A lot of guys put it in the charge pipe. That's only because a standard intake manifold doesn't have a location. There are benefits to picking the boost up here. When you close the throttle, or if you have a throttle closure, you will get a boost spike. That will keep the port injection pumping and keep the secondary fuel pump on when it's not actually needed in the engine. Something to keep in mind. Been talking to a few people about actually getting the port injection boost signal from inside the manifold instead of the factory T-map, which is on the wrong side of the throttle body. Anyway, we've gone off topic. So the secondary fuel pump is going to activate when we're over 14 psi, and that is going to send fuel from the secondary pump, bypass the regulator up to the front of the car, and actually tee into this little assembly here. That line there is for the factory fuel line. It's the original 1/4 inch or -6, and then the secondary Walbro is going to come into this line here. It's still going to feed into the high pressure fuel pump. It's still going to be basically getting a pressure signal on there, but at 14 psi of boost, when that secondary pump turns on, we're going to have a hell of a lot of fuel here. Basically going to be maxing out the Walbros. The intention is you're going to be using the fuel, so you're not going to get any crazy psi. In fact, the Walbros have bleed-off valves anyway. At a certain psi, they just circle the fuel. But I think the 525 might be at like 100 psi or something. Somebody will correct me. Anyway, we've got all this extra fuel here, unmetered or unrestricted by the factory fuel regulator. It goes up to the port injection rail. That is where it goes into the rail, which will be at the front of the engine. Then the fuel comes through the rail and it will go down into the fuel pressure regulator. In fact, that's what that line is there. So it'll basically come up into the fuel rail. Imagine the fuel rail in this gap here, and it comes back to the regulator. Now this will close off. I need to actually find out what this is set to. All it needs to do is be set at like 70 psi. As long as it's set lower than that one, it's going to work perfectly, and it will stay closed unless the fuel pressure is over 70 psi at this point right here. Obviously, that is 70 psi boost reference, because we've got boost coming in through this line here. I hope that makes sense. That was a big, long, 12-minute one take, but that's the fuel system explained, and it's this little regulator that's going to keep 60 to 70 psi in this fuel rail instead of it dropping down when you've got boost pushing up through the injectors. I know the injectors open and close, but when you've got 30 psi on this side of the injectors, it pushes the fuel back. As soon as the injector opens, it will push the fuel back up into the rail. So we need to offset that with this little sucker here. That's the magic of it. Man, it's been raining a lot today. Sorry there's not been a lot of filming, but when the this La Nina, or whatever the hell this weather cycle is pouring, you just can't hear anything in here. I'm going to get on with installing it. This video is long enough, and I'm just going to crack on and get the work done, to be honest. I'm going to be cleaning the valves. Did I show you guys that? I can't even remember if I showed you guys that. We have taken the intake manifold off. The valves are actually relatively clean. I'll flash up a picture of them. But I'm going to get the walnut blasting done, and then basically fit that fuel system. Sounds easy, doesn't it? Should be easy. I took it out of O'Reilly. Dan from Simply Tuning, you're a G. Thank you for putting this together. And it's going to work. All right, guys. See you tomorrow. Hopefully we fire the car up with flex fuel. Peace.